What you see on this little screen is a window to 1986. These are tons of radioactive graphite thrown around after the explosion of the Chernobyl reactor 4. And even a short contact with that could cost a house or even a life for a human. So to deal with that, they needed the machines, while remotely controlled mechanisms became the hands of Chernobyl liquidators. These huge robotic cameras became their eyes. So today we are going to look to little known devices that in reality saved a lot of lives because they became electronic eyes during the Chernobyl disaster. To learn more, we contacted Michael Bukov, who since 1987 and for many years was an electronics engineer responsible for these robotic TV systems in the disaster zone. The camera is notably really huge and it weighs around 10 kilograms. In fact, it actually even has a handle to carry it, which is hidden inside the bottom pod. Using this pod, you can place it on a stationary position on this kind of mount, or, as in our case, we have a robotic manipulator that will tilt and rotate it by remote commands. You connect it using this connector, which is placed really deep and secured by bolts to avoid any moisture coming inside. This overall sturdy look in reality is not just so, because it all fully watertight and can work in really extreme conditions. However, we really wonder why it is so heavy, so let's open and look inside. And here is a little trouble because there is a very special asymmetric screw here that is very hard to take out unless you have this special key. You can see that it is even rounded, so you can't catch it with, say, pliers. Then we slowly and carefully pull the internal part out, and you have to say that already looks pretty interesting. Well, for now it doesn't go far because we need to disconnect the front visor heater. Yeah, because you actually can remotely warm up the glass if you use it during, say, heavy freezing. And then we can pull everything out completely. It sits on kind of rails inside. This is, by the way, what the heater looks like. And this is what we have inside. Just look at this. Wow, that's really impressive. Not only how it is packaged, but also the quality is also notable good because all socket boards they are in a protective varnish, all wires are well secured, so well, that's far above what quality of electronics was available to average Soviet citizen. Look, it even has a safety switch that prevents powering it all on if the casing is open. That's really cool. The centerpiece is a huge Vidicon CRT tube. Well, if nowadays all the cameras we know are based on a solid state sensors, in the end of the 80s those chips just appeared. And a vast majority of cameras were still based on such kind of cathode ray tubes. There were pretty many types of them, such as iconoscopes and orticons, but Vidicon is one of the latest developed types. The principle of operation may sound complex, but in fact it's really interesting. The image focused by the lenses makes an irregular charge on a special photoconductive layer, which is later being scanned by a beam of low-velocity electrons. The optical system that captures the image is really interesting. Surprisingly, in all these CCTV cameras, they used photography lens, mostly, but not limited to, it was a Helios 44-2. This lens you can find, for example, in the iconic Soviet Zenit camera. This set is a Soviet copy of Carl Zeiss Biotar 58mm lens, and it was perhaps the most mass-produced of this type. The difference to a photo camera, however, is that in CCTV cameras this lens is motorized. There is a little electric motor and a set of gears that allow to change the focus by a remote command. And in some more advanced modifications, there was also a zoom functionality. This camera unfortunately has only a focus control. To detect the minimum and maximum positions, there are two hidden micro switches, and all this is connected to a decoder of a common signals. The raw video signal that comes from the vidicone has to be prepared for further transmission, so most of that electronics inside our camera, which surrounds the tube, does exactly this task. This block with a few potentiometers is an amplifier that makes the initial signal processing. This board with a lot of gold chips is a Syro generator that provides signal interlacing to 625 lines by 25 frames per second. And this large socket board is a scan generator. So, after all, you receive a normal TV signal that you can plug straight to the television set right away. So, this is what we are going to do right now, because we are going to assemble a functional robotic camera system exactly like it was back in 1986 in Chernobyl. To control our camera, we will need this PTU51 control panel. This device can manage up to 8 cameras, and depending on the configuration chosen, you can manipulate the position, focus and zoom. It also provides all the necessary power voltages to the cameras. And on the back there is a toggle switch to start the heating of the visors, and also here is a huge connector. Using it, it has to be connected to a signal switch that provides the camera select and then collects a video signal from the active channel. So this switch can be connected to a monitor and optionally a videotape recorder, basically exactly like this they did in Chernobyl. Later, they were developed newer, more sophisticated generation of these CCTV systems, and those already allowed to make such things as picture-in-picture or to add text notes over the video, and so on, but those were too complicated and they were not used in the Chernobyl zone. We, however, do not have that switch, so our setup will be a little bit more simple and will look like this. Normally in these systems, they were using special 20-inch CRT monitors to watch the recorded footage, but in Chernobyl they used them in a bunker for a live footage coming from the robots. We actually have such a display, but it doesn't work well, so instead we will use a 9-inch display intended for live transmission control in these CCTV systems. It's interesting that this display has a signal bypass, so actually you can connect many of them in a chain. And also there is a switch that changes the resistance of the line to 75 ohms, which is required by some types of these cameras. And notice this blue connector. That is exactly for integration with that newer digital systems we just mentioned. So first we install the camera on its manipulator and plug in the bypass cable. Given that from the camera actually comes two cables, one for video and one for control, we will plug one of them directly to the monitor and another one to the control panel directly, so that has to be sufficient. Now we power on the control panel and choose the channel 1, and here we go. And it works. As we can see, the image is, well, far from good. This is because the Vidicon tube in our camera is already probably pretty degraded after all that years. But for this little test of a 30-year-old device, this is pretty fair result, we think. The camera itself can move to 270 degrees around and within 90 degrees up and down. And here we can see very well that image inertia. This where a camera doesn't have any zoom functionality, so the distance to the object has to be at least 2 meters. Actually, I completely love that when in operation there are all these relays and switches clicking inside, gives a really cool feeling, I have to say. This manipulator actually is designed pretty interesting as well, so I removed the side cover. All this well bolted and with the inside rubber insulation against the moisture. So here we can see two motors, one to rotate it and one to tilt it. There are also these micro switches that indicate when it reaches a maximum position, so motors will stop. And the tilt mechanism has such an interesting coupling. Honestly, I forgot how it is called correctly in English, so please advise in the comments. And it also has that hidden switches for the lowest and highest position, which are hidden behind that protective cover. So this is what it looks like in the action. In our talks, Mr. Bukov recalled a somewhat funny episode. So, as I told before, these cameras were very vulnerable to burnout in the case of a strong light coming directly to the tube. So, he had the same camera stored for a while in his workshop at the Jupiter plant in Pripyat, and it was looking to the window, and behind that window was a usual fence made of a metal grid. So eventually, the contours of grid imprinted into Vidicon, and the camera has been transmitting the image with such an artifact. But less funny it was when it came to radiation exposure, because the cameras you can see, for example, on this very picture, likely would last not more than 1 week, because their levels of radiations were extreme. And Mr. Bukov told me a similar episode. In 1986, there was created a so-called Pidlisny radioactive waste repository. That place consists of a few large concrete, like wall-shaped modules where extremely dangerous debris was collected. So it was that extreme there that there was even installed a remotely controlled crane, but it was not enough. They needed to look what is going on inside that modules. So they made such a makeshift shaped mounts with the video camera bolted at the top, and using that crane, they just placed them atop the wall. And these cameras lasted not for long, kind of a month or so, so presumably they're still there, but already long dead. In his book, Mr. Bukov has a story about so-called Beloyarsk project, also developed by Spetsatom. It was kind of a very huge portal crane-based robot that was designed to dismantle the active zones of reactors when they reach an end of their lifetime. There were used KTP-64 cameras, which perhaps are the weirdest looking from all we have seen. Originally, they were designed to be installed in places of a limited space, therefore this camera is vertical and the tube is positioned vertically as well. So let's dismantle, and what's inside, I have to say, is truly epic piece of engineering. Unfortunately, it has a dead tube, so all we can is just to manipulate its position. And to look left and right, the entire camera has to rotate. But the tilt is made using a moving mirror which has a set of gears attached. So why this is better? Because the thing is, in high radiation conditions, when there is a strong beta radiation present, this mirror prevents the rays getting to the aperture of the tube, and the tube itself is completely shielded with a thick metal enclosure of the camera. So supposedly they would last much longer. And in other aspects, technically it is the same as KTP-63 with the same Helios lens, but everything here placed differently and all the parts are much more exposed. However, well, we didn't risk to dismantle the base rotation mechanism, but supposedly there is a small motor and a large gear. Nowadays, there are newer generations of this kind of cameras. They design it specifically for such environments. They look a little bit different from outside, but they also vertical and have this kind of mirror as well. So these two type of cameras were not the only existing. There were more sophisticated systems of this kind, and in a full version of the video you can find on our Patreon, we reviewed a newer KTP-83 camera as well. So link is in description below. And in meanwhile, don't forget to like this video and subscribe to our channel, because a lot of really epic things are coming here. So that's it for today. Thank you for watching and see you next time.